Hi guys, this is Nitin and I am back again. This time I'm going to talk about a little bit of backend engineering. AI application development is booming and everyone is talking about nowadays, but very little time the other perspective is also talked about, that is software engineering. If you want to move into production and do something which is useful, which makes sense and solves the purpose, you need to have a balance of both AI engineering as well as software development. So in this video, I'm going to dive deeper into how I am processing some of the data for product price history. So if you guys remember, I showcased this project a few months ago, and you guys seems to love it. I received a lot of comments and other things. So obviously, I think this project is what everyone is interested in. So this video is going to be a continuation of the same project, but this time instead of talking about more deeper into AI, I'm going to talk about how I'm managing the price history. Now, what is that? So before I do that, let me just process one or two images to show you an example and the problem which I'm solving. So you see, I have these two images here right now, which are processed, and for some of the products you see the price is detected from the image itself. You can see it's 6.65.90 and it is able to pick this up from here. But if you notice, for some of the products this might not be the case. Problem could be that the price tag is not properly detected or not recognized. And not only that, we don't want the current price only, but we also want like additional information about price, that is price history. So this product might be listed into multiple marketplaces at multiple locations and may have varying price tag values. So we want to integrate this feature into this application such that any user would be able to know and visualize how the product is performing in the market and at what price it is being sold at. So to do that, the best data source that we have is to be able to scrape the product information from different marketplaces. Now it comes with its own problem, that is, if you see, we have this data delivery tab here where we have all the listed products in our application, and we have also uh, assigned the SKUs, which are the standard stock keeping unit numbers for the product. The problem is when this product is scraped from different market sources, they might have a different or varying SKU, and which might not match with our internal database. So we needed a logic where we would be able to match these products against these scraped products. And another problem is because we are scraping the same products again and again over time to get the price history values, it's become difficult to have all of those data aggregated at one place to be able to see the price history. Let me show you an example of how our scraped data source looks like before I move forward. So if you see here, these are different markets which we are scraping right now, and this is one document which is the instance of a product at that point, which shows you the date at which this data was scraped at, the price value of that product, and what city it was located at, and other things. Now this product ID is something which we have to think about and come up with. So we basically are using this image and then product name combined and then creating a hash out of it to be used as a product ID. This is like a temporary product ID, and that help us to basically aggregate the same products fetched from same sources. So if you see, if I search for this product ID, I get these many results, but essentially these all belong to the same product, and only varying thing is they might have a different price value, although because these are scraped at a different scraping sessions, their price tag is still same, but you will see in certain cases that the price tag value will also change. So we have to deal with a lot of things. That is, if the information is redundant, if the price tag value is same over different scraping session, we don't want to keep multiple copies of the same value. And if it is changing, then we want an aggregated array where we have price tag values, and it's like history over time. So we first need to process this data. And if you see, if I remove this, you can see we have like close to 1 million records in this one single source. Then we have other sources as well which might have more data. So the essential task here is to process all of these data in as much time as possible, because we have to do it occasionally. Every time we run a scraping session, we also need to process the data to be able to index it and then later search it. By the way, I haven't shown you, but we are using Search here to be able to search through our products in our internal database. This is not the scraper database, this is our internal product database. So if I want to search for, let's say, pasta, I will be able to see these products and see the information. So essentially what we want here is we want a feature where we would be able to see the price history over time for this product, and the source would be the scraping sessions that we run. So similar to this, I have already created the API for this project. So if I, let's say, open this product maybe, or let's say this one. So this is seems like a orange juice, and I have this endpoint which I have been working on. It's not integrated in the UI right now, but the backend actually works. And I want hits per page as 10. Okay, and execute. So you see we get these many results. These are basically uh, product information from the scraping sources, and we have a price history here which shows you the change in price of this product over time and at what marketplace or date that price was available for. So this is what we are going to build the backend part to be able to get this data quickly for the product, and this will be later integrated into the UI to show a graph on how the price is changing over time for this product. So this one is working right now, but we are going to write code to show you how the aggregation works, how the indexing works, and how I'm able to search it, and what logic have I applied so that if I have to run the indexing again and again, so I don't have to process all the records every time, and only the newly available records will be added into the existing index to save up some time and quickly build our index. Okay, so here we are in our notebook, and as you can see, I have already loaded the MongoDB URI to connect to the database, and a Search API key which I will be using to connect to my locally hosted Search instance. You can go and search for Search Docker Compose to host your own instance of Search, and here you can see this example which you can use to host your own instance and then connect to it. Right now for me, I have already hosted it locally, so I'm just going to utilize it. And so let's start with the basic exploration, that is, let's connect to our database and see what information is available there. So I would need to create a MongoDB client. So from PyMongo import Mongo client, and I'm going to copy paste some of the codes because I don't want to waste our time. So because I already have the code available, so I will just go through it by pasting it and then talking about how it all works. Let's create a Mongo client to be able to connect to the DB. So Mongo client, and Mongo client will be this using Mongo URI, and then we need instance for the MongoDB where our data lives. So this will be like using Mongo client and then passing a DB name. So DB name in our case is my database. So I will be just writing it here for now. And with this, we have an instance of our Mongo database. Now our data lives into multiple collections, and I have those collections listed out here. So I will just put it like this. But this is a list of collection that we want to collect, and in our case we have to create an instance of this collection from the database itself to be able to access it. So a better way is to store the collections in a dictionary with the collection name as key and value as the instance of that collection. So what this will do is it will create a dictionary with the collection name and then instance of that collection. So let's execute this, and we don't have PyMongo. All right, so I need to install PyMongo, and I will just list out exact version which I want, that is 4.10.0. So let me do that. So now that we have an instance of our collection, we should be able to query it and see the data inside it. Now, if you remember, we had this kind of database, data in our database, and a lot of products will be repeated based on the product ID. So what essentially we want is we want all the unique product IDs in our database so that we can iterate over them and then fetch all the instances of that product ID to be able to use it for aggregating the price history values. So I'm going to write a function which will allow me to iterate over the product IDs. I'm just going to now copy this logic here, and I would need to modify this a little bit because this is part of a class, and here we are not writing it inside a class. Instead, I'm just writing it as a function. So iter unique product IDs is your function which will allow me to iterate. So basically here is our pipeline. What it does is it creates a pipeline where we group the product based on the product ID, and right now this function is only going to just return us the count of those IDs. So this is one function, and another one here is again going to create a pipeline which will just group them by the product ID. And since we have multiple collections and we want to iterate on all of the collections, that is why I have to iterate on those collections while creating the unique product IDs. I am also using this get unique product ID count so that I get a total number of products which we are getting, and that I can use to create a progress bar. Now to use a progress bar, I would need to import tqdm. So let's do it here from tqdm import tqdm, right? So we get a total, that is how many data points we are going to get out of all the collections that is available to us. We have these 1, 2, 3, and 4 collections. So I'm going to iterate on those collections and then get unique product ID count for those, put it into total, and then I'm going to use this iterator function which I created here. So basically if I put a yield here, instead of returning, it will just yield that product information, and if I try to iterate over that, it will just keep on continuing until the data is finished. So I'm iterating here for product ID in unique product ID is iterator, and I have to use this total. That's why I return a function here to get the total ID count. And I am also defining a batch size because if I have to do it one by one, that will take a lot of time to process the data. So again, this is another iterator which will allow me to iterate over all the collections and then all the unique product ID inside those collections at once. So that is why I have this iterator in place. If I try to use it, so if I want to use it, this is going to return me product IDs. So for product IDs in it iter unique product IDs. Let's try to print this. I'm going to keep the batch size as 1 for now for testing purposes. And let's see. Okay, so we get some data, right? If I put the batch size as 2, this might also return me 2 unique product IDs for that. You can see we have 2 documents here, and this is returning me the collection where this product ID lives and the actual product ID. Now this is renamed as an ID because of the pipeline aggregation, but in general we get an idea that out of all the records in our database, we get around 58,000 records which are unique product IDs across all the collections. So now we have a way to iterate on products in batches using this match and group. By the way, I also have this match filter here in place which I will be using later. So essentially that will be used to filter out the products which is already indexed, so that if new data is scraped, we don't have to iterate on previous records because that is already processed and put inside mealy search index. So we can apply a filter and we don't have to iterate on the older records. That is why I have this filter in place which I will be utilizing later on. So here I get the product IDs, actually unique product IDs out of all the collections. And now my goal is to get the product instances out of these product IDs. So to get that, I would need to write a function which will get me the product by ID. So define get product by IDs. Okay. So I'm going to again copy paste this function now. This is a large function, but I will talk in detail about how all of this works. Okay. So get by product IDs. This is where I will send a list of unique product IDs to this function, and it will be returning me the product information for that product ID. And see, this product ID can be part of any collection. So so that's the reason while iterating on unique product IDs, I was also returning the collection name so that we know where to get the product information from using this product ID. Here what I'm doing is basically grouping the product ID based on collections, because we get a list of product IDs and collections as a dictionary, list of dictionaries. What I'm basically doing is I am grouping the product IDs into multiple groups. So each group belongs to one collection, so that in batches we will able be to get the product information for that particular collection directly. So this is what I'm doing here. And then here I'm, for each collection I am creating the query, that is product ID in IDs, set of IDs which will be fetched from this collection. And finally I am running the query here. So self.collection, I need to update the code a little bit because I've copied it now. So instead of here I will be using collections, because that's essentially what I have stored here as a key value pair for collection name and collection instance from the MongoDB. So here we group it, and then we are iterating on the collection, and then for each collection we are forming a query and also possibly applying filters, and we are getting all of these data in case we are passing any projection, that is what keys we need from the product, because these are essential, so these needs to be included in those cases, otherwise it will just return all of the documents. So here I run the query to get the product information for the given product IDs from all of the collections available. And here is some extra logic. What it does is basically it filters out the unique price values. So what happens is during multiple scripting sessions there will be multiple instances of the product where the price tag value will be same. So we don't want to keep the redundant values. So what it does is it checks if the user is passing that they want unique prices or not, and based on that basically it is going to maintain a dictionary where it says if it has seen that price tag value before or not. If that is not seen, then that will be updated in the temporary list, otherwise it won't be. And finally here we are returning the final records. As an extra step, I'm also returning the duplicate records because we need to update those as well, that this has been indexed, so that in later when you want to iterate over these data, newly scraped data, we don't want to iterate on these older records which were never processed. So I think this should work now. I don't have any dependency. So get product by product IDs. Okay. And here we have a batch size of 2. So products equals to get product by product IDs. Let's see if it works. Okay, so we had a batch size of 2 and we get the product information for 2 product IDs. Let's do it for one itself. So now what I have to do is I have to create the price history array out of this information, because I know this is all the unique price tag based product information for the given product ID. In this case, since it's a single instance, so I am getting a single dictionary for this product ID. But if we have multiple entries, we would get multiple. What I need to do is combine all of these data into a single data, because the product name information, category information, other things will be same. The only additional data that we will be producing is the array for price history. because now these are currently part of different documents. I need to put them in a single document. So to do that, what I really need to do is I need to iterate on these products and create the price history. So for product, in products, basically iterating on all the instances of that product ID. For product in products, we get we are basically converting the product ID into a string, because object ID by bson is not very useful here when we want to index it as a string. I'm extracting the product ID here, and then I need to maintain a history. So I'm going to utilize default dict for that as well, which I will do here. Okay, so I am defining a history variable which is an instance of default dict, and the default value will be this. So it will have product ID, price history, and duplicates which I want to store for that. Duplicates, I am already overwriting it here. So what it does is basically whenever I get a key for from the history dictionary, it will automatically create a value for it with these default keys, and then I can just update the information. So here what I'm doing is I'm getting this entry from the history default dictionary using this product ID, and it will always get me this dictionary as a value for that dict. And what I can do is I can just update the dictionary with all the product information which I'm receiving from the database, and at the same time I can add just because this price history uh, list will be already populated there with a blank list obviously, so I can just directly append to that list without even creating that list for that dictionary. So that's benefit of using a default dict, that you get a already populated values for the key that you requested with the default values that you want to use. So I'm creating a price history list, and inside which I'm storing these information. So with this we will have a product. Let's try to print. So we have product ID stored here, and then price history, which has all the instances of that product, which have different price tag information across different records. So now what I can do is I can basically wrap this function again, and this whole logic inside a function. So basically, if I am now going to use this function as an iterator, so if I just call it like this for products and iterate, this will essentially just give me all the products, unique products, along with its price history values aggregated over using product IDs that I can use for indexing purposes. So instead of going through all of these records, it will just give me the record which has a price tag value aggregated. Now if I say batch size 1, I'll get a single product along with its price history. And if I say batch size as 2 maybe or 10, I'll get 10 products aggregated, and each of the product will have its price history. So with this I'm able to iterate on all the products in the database, and also getting the price history aggregated for each unique product IDs. Now what I really need to do is I need to index this, and indexing basically means I need to put this in Mealy search so that I can use the text features to be able to search through the information. The good thing is with Mealy search I can just put the whole document as JSON, and I can search through any of the parameter key or value of that document without explicitly specifying, and it works great out of the box. To create a client, I would need this code. Client equals to mealysearch.client, and then host, as far I remember, as because I have locally hosted this mealysearch instance, and it is running on port 7700. API key, I already loaded it from the environment, so I should be able to use this as well. So I've created a client for the Mealy search, but I also need to create an instance of index. Index name, I need to pass that as well. So index name could be, let's say I'll call it temp index for now because this is just for testing purposes. So client.index, this will give me an instance of the index, and I should be able to put data there. So let's try to do add a dummy record. So index dot add add documents. Okay, so it receives a list of documents that needs to be added. So because I only have a single instance here, I'll wrap this inside a list, and let's do something like this. Let's try a dummy record first. So this is an example from their website only. So I just put something like this, and I need to call this. Okay. So I think with this, the data should be inside the Mealy search index. And as an example, let's also try to search through it. So index.search. Let's put the query something like Carol. Okay, we get a hit. If we search with drama, we are still getting. So basically, this is how Mealy search works. You put any dictionary or JSON document, and then you can just pass a single string query that you can utilize to search through the whole index. Tested it for so many records, in millions of records. It works flawlessly on CPU, so the performance is on par, and that's what I like about it. Now our goal is to basically index all of these documents which we have created as an price history aggregate. And since we are getting the list of products directly, so I should be just able to, okay, remove the print statement. So I'm now able to index the product. Let me run it for all the products that we have in our database. I'm going to use a batch size of 1000 and see how much time it takes to index. So we have 58,000 unique product IDs, although the actual number of entries for each product ID, if I count them, will go into millions. But it is showing me that we will be able to index all of this data in the next 1 minute. What's great than that? Because we're using a batch size of 1000, we are able to quickly do it. And you see, because we're doing it for the first time, it has to iterate on all the possible instances of each product ID, and that is why it has to iterate through these 58,000 records, and it takes time, right? And in the future, if we do more scraping and we need to update our index with new data, this might take more and more time to process those. So for that exact reason, I have few more logic in place where what I do is I mark the document as indexed, and then while iterating onto the documents in the pipeline, I add a match statement where I say if the product is already indexed, do not include it. Now the problem what appears after that is if I don't include those documents, and if I only list out the latest document from the scraping session for indexing, and I update the document inside our index, what it does is it will override the price history information that we have in our index, which means the previously indexed record will be overwritten. To come up with that problem, what I do is basically before indexing or adding document into the index, I check if the document with that ID exists or not, and if it exists, then get the price history information from the already indexed product inside Mealy search, then use the price history value from there which was already indexed, and the one which we are getting from our scraper db with the filter applied, so we get only new records, and then combine these two to put it in our index. And this way I really do not have to iterate on all possible data from the beginning to update our index of price values information. Currently I'm just directly accessing the index and adding documents, but that might not help me with the update process, where if I am iterating on latest products, it might override the previously stored price values or price history. So I will create another function called add documents, and so far the logic was simple, that is simple index dot add documents, and docs, right? But the only problem which we have here is it will override the existing document with the same ID, which means we don't get the price history values. So to do that, I would need to write a function which will search for the existing documents. So let's say updated docs is blank, and we would be adding this updated docs inside our index. Now, how do we update the docs? So basically, we will first need to search the index. So let's say for doc in docs, let's iterate on each document. Heads is equals to index dot search. I'm going to search inside this index with this ID, and the parameter would be hit per page as 1 and get hits. And if I see that if there is any results with that ID and the this current document ID and then the hit, which is basically search result ID, it's same. So I need to what I need to do is I need to update this document and the price history value of this document with the uh, hits, that is search as price history, and the current price history from the document which is we are getting from the database. Now if you see, I have this additional function wrapped around here, and what it does is, because it's a dictionary, and it might be possible that the previously stored document and the one which we are getting from scraperdb might be same, so we will get redundant price history values which we might not want. So easy way is to use a set to remove the duplicates, but because these are list of dictionaries, so the set is not able to hash that item, and we are not able to create a unique set of price history values from there. So for that I had created a unique auxiliary function, that is get unique entries, and what it does is basically uh, act as a set on list of dictionaries to get the unique entries out of this. So we use previously stored price history values and the newly, which is getting from we are getting from our scraperdb, and then update our doc if it exists in our index, and then update our index with the latest document. So instead of index.add documents, I just call add documents function with the products, and it will make sure that my price history is intact. Even if I send partial data or newly data only, the previously stored values inside that array will be stored in place. And this will be very handy when I have to run the indexing process again, but this time with the filtered values, so that I am not scraping or iterating on the previously already indexed products. So I have this implementation here, and I'm able to search through it. Just look for pasta. Okay, I'm getting these documents. So obviously it's about data formatting processing to get the millisers to accept it. But in all certain cases, this is how this works. I might share you an update in the new video, but for now, I think this much information is good enough.